Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 7, 7.5, and we'll be looking at more difficult geometrical problems which involve vectors in 2 dimensions. In a previous lesson, we did look at some more straightforward problems, but there is a type of question that turns up quite frequently that we need to look at. And it uses this idea: if P and Q are 2 vectors which are not parallel to each other, and you have one linear combination of them, so m times p plus n times q, and we know that that is equal to another linear combination of them, a times p plus b times q, then that is only possible if m equals a. So the coefficients of the vector p must be the same as each other, and n equals b, the coefficients of the vector q. Okay, let's have a look at an example where we use this idea. If OPQR is a parallelogram, prove that its diagonals bisect each other. So we have a parallelogram, OPQR, and we'll let the vector from O to P be P, and the vector from O to R be R. Because it's a parallelogram, we know that PQ will also equal OR, so PQ will equal R, and RQ will be the same as OP, so RQ will also equal P. What we do is we find the vector from O to M by 2 different routes along the 2 different diagonals. So first of all, we'll go the more straightforward route. So to get from O to M, we need to go along the vector OQ some distance. Now alpha there is saying what fraction of the distance we need to go along OQ. So OM could be 1/3 of the way along OQ. It could be 2/3 of the way along. What we're trying to do is prove that alpha equals 1/2, that it's 1/2 of the way along OQ. And then that'll make M the midpoint of OQ. We then do the same thing, but using the other diagonal. So we'll go from O to M again, but this time by going from O to P and then P to M. And we use the same idea with PM. We say PM is some fraction of the way along PR. So beta again is a fraction, and it could be 1/3 of the way along PR, it could be 1/4 of the way. We're trying to prove that beta is 1/2, that it's 1/2 of the way along PR. And if that's the case, then M will be the midpoint of PR. And if both alpha and beta are equal to 1/2, that'll mean that the diagonals must bisect each other. Now that's the idea. I'll let you have a go at working that through in practice. So writing down all of these vectors in terms of the vector P and the vector R. I'll let you have a go, pause the video, see if you can make sense of this, and then come back to me when you're ready. Okay, let's have a look. So that's what we said we're going to do. We're going to go from O to M by 2 different routes. First of all, some fraction of the way along OQ, and then secondly, by going to P, and then some fraction of the way from P to R, where alpha and beta are those 2 fractions. Looking first of all at the first route, equation 1, OQ would be OR plus RQ. Now RQ is just P, so the vector from O to Q will equal R plus P. So OM is alpha times R plus P. Now looking at the second equation, OP is just a vector P, then we've got beta. And the vector from P to R, as always, we do the position vector of R, take away the position vector of P. So we'll have R minus P here for the vector from P to R, but you can see on the diagram, that is what it is. You'd have minus P plus R. Then what we do is we say, well, both of these things must be the same as each other because they are both the vector from O to M. So the first thing, alpha into R plus P, must equal the second thing, P plus beta into R minus P. Now, if we multiply out the brackets, we'll get alpha P plus alpha R here. And here, multiplying out the brackets and collecting together the terms in P, we'll have 1 minus beta times P plus beta times by R. And the reason why we've written it down like that is we can now use that rule that we said at the start of the lesson. So you've got some linear combination of P and R is equal to some other linear combination of P and R. That means the coefficients of P must equal each other, the coefficients of R must equal each other. So that's the idea we're using. Equating the coefficients of P gives us alpha on the left-hand side equals 1 minus beta on the right-hand side. And equating the coefficients of R gives us alpha on the left-hand side equals beta on the right-hand side. Now we just have a simple pair of simultaneous equations that we need to solve. If we add those two equations together, we'll get 2 alpha equals 1, which means alpha equals a half, which is what we were hoping it equaled. And then going to the second equation, alpha equals beta. So if alpha is a half, then beta must also equal a half. Therefore, M is the midpoint of OQ and it's the midpoint of PR. And therefore, the diagonals of a parallelogram do bisect each other. Okay, example 2 is a little bit more confusing, but it uses exactly the same ideas. This time we've got a square, OQRS. M is the midpoint of OQ. And the more confusing thing is this. T divides RS in the ratio 1 to 3. So the ratio RT to TS would be 1 to 3. If the vector from O to Q is Q and the vector from O to S is S, what we're going to do is what we did before. We're going to find the vector from O to P by 2 different routes. So first of all, we'll go from O to Q and then some fraction of the way along QS. So alpha times by QS. The second thing we're asked to do is find the vector from O to P again, but this time using the other diagonal. This one is slightly more tricky when you come to do it. We're going to go from O to M and then some fraction of the way along the vector from M to T. And same as in the first example, once we've done that, we'll say, well, both of those things are the vector from O to P. They must equal each other. We'll equate the coefficients of Q, equate the coefficients of S, get a pair of simultaneous equations. We'll solve them, find alpha, find beta, and then hopefully we'll be able to do part 3. Now, I'll let you have a go at working your way through all of that yourself. So pause the video, see if you can make sense of this, and then come back to me when you're ready. Okay, let's have a look. So part 1, we're asked to find OP equals the vector from O to Q and then some fraction of the way from Q to S, which is what QP would be. In terms of Q and S, well, the vector from O to Q is just Q. QS, as always, we do the position vector of S, take away the position vector of Q, so we'll have alpha times by S minus Q. Multiplying out the brackets and collecting together terms, that gives us 1 minus alpha times Q plus alpha times by S. Part 2 asks us to find the vector from O to P, this time by going from O to M, and then some fraction of the way from M to T. So O to M, that's a half of OQ. So it's a half of the vector Q, because M is the midpoint. And then the vector from M to T is the tricky one. And the route I'm going to take from M to T is from M down to O, then from O to S, and then from S up to T. From M down to O, that'll be minus a half Q, because we're going backwards along that vector, then plus S, which is the vector OS, and then 3/4 of the way up Q. So the vector SR would be Q, because it's T divides RS in a ratio 1 to 3, then to get to T, we'll be going 3/4 of the way along Q. Then we multiply out the brackets, then we collect together the terms, and that'll give us a quarter beta plus a half times by the vector Q plus beta times by the vector S. So that's what we've done so far. We've found the vector from O to P by 2 different routes. The first route gave us that as the answer. The second route gave us that as the answer. And now we need to use this to show that the ratio QP to PS is equal to 2 to 3. Same as in the first example. We equate the coefficients of Q. That gives us 1 minus alpha is equal to a quarter beta plus a half. Equating the coefficients of S just gives us alpha is equal to beta. The first equation, if I rearrange it, that'll give me minus alpha equals a quarter beta minus a half, and then moving everything to the opposite sides, that'll give me alpha equals a half minus a quarter beta. If I substitute that into the second equation, that'll give me a half minus a quarter beta is equal to beta. Rearranging that a little gives me a half equals 5/4 beta, and then I can work out what beta is. It'll be 4/10, which is 2/5. Now beta equals 2/5. The second equation says that alpha equals beta, so alpha must also equal 2/5. Now we're as good as home and dry now. So that's what we've done so far. We've shown that alpha equals 2/5. We've shown that beta equals 2/5. But going back to how that's applied, QP was equal to alpha times by QS, that fraction of QS, which means that QP is equal to 2/5 of QS. And that means that the ratio QP to PS must be 2:3. Now, the same thing would also be true if we found the ratio MP to PT. Using 2/5 for beta, that ratio, MP to PT, would also be 2:3, but we weren't asked to find that out. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 116 and have a go at exercise 7E. Thanks very much for listening, and cheerio.